So as we start talking about wastewater treatment, this is the first video in that, and we're going to talk briefly about preliminary treatment. Preliminary treatment is the first step in most wastewater treatment processes, and it's maybe in some ways the grossest step because it's the closest to raw sewage that we need to deal with. So what is the purpose of preliminary treatment? Well, the goal is to prepare for further treatment. So what does that mean? Well, we want to remove things like oily scum, floating debris, grit, anything that can damage mechanical equipment downstream. So there's usually some pumps in wastewater treatment facilities, pipes, overflow weirs, things like that. We don't want it to get clogged by sticks and anything else that could enter the sewer system, or anything that would interfere with any kind of biological process downstream. So there's usually three components. So the first one is what we call screening, and this is achieved using typically bar screens or bar racks. And the purpose of this is to remove coarse solids. So this is things like sticks and tires and things like that. Rags and floatables is a euphemism for some of the things that can be in there. This is a little cartoon from your textbook showing a bar screen where the wastewater goes through these kind of screening looking things. Here's a picture of bar screens where the wastewater is going through, getting caught on the bar screens, and then these are constantly being rotated around a couple of like pulley motor kind of things, where on the back side you might have like a dumpster or something that this is getting discharged into. And then after screening, the next step is grit removal. So in addition to coarse solids, we have typically things like sand and gravel, or things like eggshells, bone fragments, hopefully not human bones, but you know, chicken bones and things like that, fruit and vegetable seeds, and coffee grounds. Essentially anything that's fine solids that wouldn't dissolve or break down in the sewer system itself. We also don't want those getting through into our treatment facility. And so there's a couple of different ways of doing grit removal. A common way is grit chambers, or aerated grit chambers. So here's a picture of one. Essentially, if we're looking at it in cross-section, we have established in these grit chambers, you have air being pumped in, and the air creates this vortex. And in so doing, the solids get carried along with the vortex, and then they're heavy enough that as they get down here, they're not able to be re-entrained in the vortex, and so they get deposited down here and then taken out. This picture right here shows what typically happens. You've got the air coming in the bottom, the flow coming in the top, and you get several cycles of that sort of cyclical or helical liquid flow pattern before the water comes out and the grit gets removed along this bottom channel. So these two, screening and grit removal, are present in almost every major wastewater facility. But the third process is only present in some, and that is equalization. Purpose of equalization is to dampen flow and organic loading rates, typically diurnally. So we know there's a daily or diurnal flow pattern that we talked about last time coming into the treatment facility, and we may want our treatment facility to have a more constant flow rate going through it. And so we provide a large tank, essentially, that the influent can come into in this pattern, and then we let water out of the tank at this pattern. And so here, where we're letting water out of the tank this way at this rate, but we have influent coming in at this rate, the water level in the tank is going to be dropping. And then starting here, where the rate coming out of the tank is less than the rate coming in, the tank is going to fill back up. And that way we can dampen the flow rate. We can also dampen the BOD loading to some extent. If this is the regular BOD loading coming in, we can dampen that to some extent as well. And not every treatment facility has this. The city of Newburgh does not really have equalization. You can also have equalization for wet weather flow. So some treatment facilities where it's very rainy might have like large emergency storage ponds that they can put wastewater in when it's really wet, and then when it's drier they can start taking some of that through the treatment facility. Other facilities like Newburgh, you might have large treatment processes downstream, like your secondary process. They have these large oxidation ditches which can just basically fill up with more water, and so they serve almost as like an equalization. Some plants will just put water through faster and have a lower level of treatment, or there's ways they can start recirculating wastewater within the plant in order to accommodate higher flow rates, so all the tanks fill up a little bit more. You have more coming in, less going out, and you just treat the water maybe several times to achieve your treatment objective. So there's different ways that is handled at different plants, and so not all have an actual equalization tank, either inline or offline, that they use. So that's essentially all of preliminary treatment, and then next lecture is going to talk about primary treatment, which is the next step in the process.